Hello class. So today we will be looking at the next part of our chapter. Okay, our first chapter, that is matter in our surroundings. So today we will be looking at the effect of change of pressure in converting a matter from its one state to another state. Okay, so in our previous video classes as well as on the Zoom live classes, we have seen that how increasing or decreasing pressure affects the change of state. We have also learned about latent heat of vaporization, latent heat of fusion, what are the processes called sublimation, then deposition, what is condensation, how latent heat is used to change a solid to liquid or liquid to gas. We have seen all this in our previous discussion. Okay, so today we will be looking at effect of change of pressure. Okay, so before going on to this, you have to remember here one statement is made, that is the difference in the physical state of every matter is due to their distance between the particles of the matter. That means the difference of the physical state. Okay, so different physical state exists because the spaces between the particles changes in every physical state. Okay, so so the spaces between the particles of solid is less, spaces between the particles of liquid is higher than solid but lesser than gases, and similarly the spaces between the gases is the maximum. Okay, so due to this distance between the particle or space between the particle, whole arrangement of the particle changes, and due to this we can see the three different states of matter. Okay, so here we'll be looking at how the effect of change of pressure, okay, how the effect of change of pressure induces a change in their physical state. So what we are doing, we are using a piston. Okay, so you can see we are using a piston, and what we will be doing, we will be applying pressure on the particles of a matter. Okay, so here specifically we are using the pressure, that is we are using a piston to apply pressure on the particles of gas, so that we can minimize, or what we can do, we can reduce the distance between the particles of gas, or we can reduce the space between the particles of gas. Okay, so how we will do it? So let's look at this animation. So look what we are doing, we are using the piston to apply pressure, and what happens, gradually the spaces between the particle, it slowly reduces. Okay, and once the spaces between the particles of gases reaches to the point which is similar to the spaces between the particles of liquid, at that point what will happen, gas will change into liquid. Okay, so that means when the spaces of the particles of gases is equal to the spaces of the particles of liquid, at that point what will happen, the gas will convert into liquid. That is, we are giving pressure to reduce the space between the particles of the gas, so that it changes into liquid. Okay, and how it will change into liquid? By reducing the spaces between the particles. Okay, so we because we all know that change of state is only and only due to the spaces, difference in spaces between the particles of matter. Okay, so we will be looking at this one. So similarly again, you can look, we are reducing the space. Okay, so that the gas changes into liquid. Clear? So from this discussion we can see that by increasing pressure, that is by applying pressure on the gases or by reducing the temperature. Okay, so what we see, that as soon as we reduce the temperature, what will happen, condensation of gases generally occurs. For example, if you consider water vapor, so water vapors are present in their gaseous state. Okay, so when you condense them, okay, what happens, what does condensation means, that we reduce their temperature of gaseous particle, especially water vapor. So what we can see, we will find that water droplets form. Okay, that means the water vapor which is in its gaseous state changes into liquid state as soon as the pressure is as soon as the temperature is reduced. Okay, so these two factors, that is increasing pressure or reducing temperature, help us in liquefying gases. Okay, so this is an important point to remember. So if any question is asked in your exam that suggest two methods by which we can liquefy a gas. So it can be number one, increasing pressure, and number two, reducing temperature. Okay. So next in your book, a brief discussion is given about dry ice. Okay. So what is dry ice? Dry ice is nothing but it is solid carbon dioxide. Okay. So generally carbon dioxide exists in its gaseous state. Okay, in its gaseous form. Carbon dioxide is a gas. We all know that. Okay. But what happens when carbon dioxide is solidified? Okay, it is converted into solid. We get dry ice. Okay. So this dry ice is almost similar to the ice that we generally find, but it is the solid form of carbon dioxide. Okay, and it is generally used for cooling purposes because its temperature is very low. Okay, so here you can look, this is dry ice, and what is happening? The dry ice is directly converting into its gaseous state in normal room temperature or pressure. That means at normal condition we have pressure of 1 atmosphere. Okay, in our surrounding, the pressure, the atmospheric pressure is of 1 atm or 1 atmosphere. Okay, so under this pressure, the solid carbon dioxide, that is dry ice, it directly converts into its gaseous form, that is directly into carbon dioxide gas. Okay, so you can see here that this solid dry ice is directly converting into carbon dioxide gas. Okay, so why it is so? This is because generally dry ice is stored at high pressure. Okay, so we have already seen that by applying high pressure we can liquefy gas. Okay, so if after the gas converts into liquid, if we give more pressure on the matter, then it may be possible to convert it to liquid. Okay, so similarly at very high pressure we can solidify carbon dioxide gas. Okay, so at very high pressure, if we apply very high pressure to carbon dioxide gas, then the carbon dioxide gas will turn to liquid, turn to solid. Okay, and this solid form of carbon dioxide is called dry ice. Okay, but as soon as the pressure is decreased, that is if it is brought to normal pressure, that is 1 atmosphere, here you can see it is written 1 atm. Okay, 1 atmosphere. This atmosphere is not the atmosphere we generally know. This is a unit of pressure. Okay, it is a unit. Okay, unit of pressure. Okay, this atmosphere is an unit of pressure, and generally in our surrounding we have pressure of 1 atmosphere. Okay, so that is generally solid carbon dioxide, that is dry ice, formed at high pressure. So if that pressure is reduced, then what we can see, that the solid carbon dioxide, that is dry ice, directly converts into gas. Okay, without going into its liquid state. Okay, so due to this also the solid carbon dioxide is known as dry ice. Okay, so this is all about dry ice in your book. So next we will be looking at the interconversion of 3 states. Okay, so these are the general graphical or diagrammatic representation of whatever we have learned until now. That is, by fusion we can convert solid to liquid, by solidification we can convert liquid to solid, again by vaporization, that is by supplying heat, we can convert liquid to gas. Okay, again by reducing the temperature we can condense gas to liquid. And what was sublimation? Sublimation was the process by which solid directly converts into gas without changing into its liquid state. And what is deposition? Deposition is the process by which gases changes into solid without going into its liquid state. Okay, so this is what we have learned till now. Okay, so next we are having a very interesting phenomena, that is evaporation. Okay, so have you ever thought that after washing your clothes you let it dry outside? Okay, but where does that water on the clothes go? Okay, so generally when we wash the clothes we wash it with water, so the clothes which are wet, they have water on them. Okay, so when you dry them, what happens? The water gets removed from the clothes. But how does this water gets removed, or where does this water go? Have you ever thought it? So is it even possible that the liquid water can be converted directly into water vapor without reaching its boiling point? We generally don't heat our clothes. Okay, to dry our clothes we generally don't heat it. Do you heat? No, we don't heat our clothes to dry. So what happens, we generally let them to dry outside. Okay, so while it dry outside, water cannot reach its boiling point. So how does this water get removed? Okay, so this is an interesting phenomena, and it all occurs due to evaporation. Okay, so now we will look at what is evaporation actually means. Okay, so what happens during the process of evaporation? As we already discussed that all the particles of a matter keeps moving. Okay, so it is a property of particles of matter that all particles of matter are continuously moving. So since they are continuously moving, they will have a energy known as kinetic energy. So we have already discussed what is kinetic energy. Kinetic energy is the energy related to the speed of a particle. Okay, so since the particles of a matter are always continuously moving, so it will have kinetic energy. But the important thing is that if you look at this particular paragraph, you will see that the kinetic energy of the particles are not equal. Okay, in a matter we have different amount of particles, different number of particles, but the kinetic energy of the different particles of matter are not always equal. So what happens in case of liquid? Okay, the particles which are at the top, okay, so which are at the surface, here you can see the particles which are at the surface, okay, at this top surface. So this is the surface, and the particles which are at this surface, what it will have, it will have more kinetic energy or higher kinetic energy than the particles at the bottom. Okay, so particles at the top or particles at the surface of the liquid will have higher kinetic energy than those at the bottom. Okay, so what we will see that since they contain higher kinetic energy, what will happen, that they will be easily able to break the force of attraction. Okay, so between two particles, what we have already discussed that between two particles we have a force of attraction. Okay, so what can these do, these particles, since these particles at the top, since they have higher kinetic energy, they can easily break the force of attraction between the two particles. Okay, between two particles we have force of attraction. So if the kinetic energy of each particle will be higher, so what will do, what will they do, they will break the force of attraction. Okay, so when they will break the force of attraction, now they are free to move. Okay, so when the particles will be free to move, they can easily move away from their definite arrangement. Okay, and the spaces between them will increase. So as the spaces between the particles of liquid will increase, slowly the liquid will change into gaseous state. Okay, so the particles at the surface, since they have higher kinetic energy, they can easily break their force of attraction and they can change into its gaseous state. Okay, so this process gradually occurs, that is first the first layer or the surface at the top, so the particles at the surface, they will get evaporated, then the next layer. Okay, so this is a gradual process. Okay, so whole the liquid or whole of the particles that are present in the liquid does not changes into gases at one time. Okay, so it is a gradual process. Okay, so since only a portion or only the particles that are present on the surfaces, it gets evaporated or it changes into the gaseous state, so the liquid generally do not attain its boiling point. Okay, so generally what happens, that liquid does not attain its boiling point even if it is some particles are changing from its liquid state to gaseous state. Okay, whole of the liquid does not boil. Okay, so that is what evaporation actually means. Okay, so evaporation is the process in which a liquid changes into gaseous state below its boiling point. Okay, the liquid does not come to the temperature at which it's boil. Okay, so for example, what we are looking at, we are looking at water. So the boiling point of water is 100°C. Clear? So when we let our clothes dry, we do not heat them. So what happens, the particles at the top surface of the clothes, they have higher kinetic energy and they will also get heat from the sunlight that is falling on them. So what will happen, so they will have more kinetic energy, so they can easily break the force of attraction between them, and that part of that amount of particles that are present on the surface, they will change into their gaseous state. Okay, that is into water vapor. Okay, so what will happen, even if the particles are not in their boiling temperature, they will change into gaseous state, and this process is called evaporation of water. Okay, so this is what evaporation means. Okay, so in the next class we will be looking at the factors that is influencing the process of evaporation. Okay, and after this this first chapter, that is the matter around us, will be completed, and we'll discuss the question answer then. Okay, so do have a look at it and try to understand the concept of every topic. Okay, so this is all for today's class. Thank you.